I ranked 3 tiny parts by how many machines they killed. Number 1 is a 2-cent can you walk past every day. A copied electrolyte formula was missing one ingredient, and it leaks. Between roughly 1999 and 2007, this leak spread through millions of devices. Dell Optiplex desktops, Apple iMacs, motherboards from nearly every major brand, whole TVs and monitors. The obvious guess is bad manufacturing across the board, but that's wrong. A single 2-cent part could brick an entire machine. And nothing looked broken until the caps physically bulged. So how does one tiny can take down a $1,000 computer? The answer is one missing ingredient in a stolen recipe. And it traces back to a lab in Japan. Start with what this part actually does. Every computer runs on smooth, steady power. But the electricity coming into a power board arrives choppy. It ripples up and down thousands of times a second. Something has to flatten those ripples before they reach the fragile chips. That job belongs to the aluminum electrolytic capacitor. Picture a tiny bucket for electric charge. When the incoming voltage spikes, the bucket fills. When it dips, the bucket pours charge back out. The result is a flat, clean supply the processor can trust. Here's how that bucket is built. Inside the little silver can are 2 thin strips of aluminum foil, rolled up tight like a jelly roll. Between them sits a paper spacer soaked in a wet chemical soup, the electrolyte. That soaked-in liquid is the whole trick. It lets the 2 foils hold far more charge in a far smaller space than a dry part could. These wet can sit everywhere the power is rough and heavy. Motherboards, the power supply inside your PC, and the power board of nearly every flat-screen TV. Dozens of them per device. And here's the catch that makes this whole story possible. That wet electrolyte is also the weak point. A ceramic capacitor is solid, dry, inert. Nothing inside it to spill. A newer solid polymer cap swaps the liquid for a conductive plastic, so there's no liquid to leak either. But the classic wet aluminum can is a sealed cup of reactive fluid, sitting inches from a chip running at 80 degrees. Get the chemistry of that fluid even slightly wrong, and the bucket doesn't just fail. It bulges, splits, and bleeds onto everything around it. So the entire disaster comes down to one liquid recipe. Who wrote it and what did they leave out? That covers the what, now the recipe itself. A good wet electrolyte is not just salty water. It's a carefully balanced blend. And part of that balance is a set of quiet additives that keep the chemistry calm under heat. One of those additives has a specific job. As the cap works, tiny chemical reactions inside try to break water apart and release hydrogen gas. The right additive suppresses that reaction. It soaks up the trouble before gas can build. Leave it out and the recipe still looks like it works. On a bench for a few weeks it behaves. The failure is a slow fuse. Here's the part that reads like a spy novel. According to widely reported industry accounts, a scientist working for a Japanese electrolyte maker copied his employer's formula. That employer is usually named as Rubicon, one of the most respected makers in the business. The scientist allegedly took the recipe with him to a new job, first in China. And staff there reportedly carried a version onward to makers in Taiwan. But and this is the crack the whole plague pours through. The copied formula was incomplete. The reports say the stolen version was missing that gas-suppressing additive. Maybe it was never fully captured. Maybe it was left out to cut cost. Either way, the copy was broken. And then it got worse because cheap recipes don't stay in one place. Low-cost suppliers copied the copy. Then others copied that. Each hop through the supply chain spread the flawed blend to more factories. And the same missing ingredient ended up sloshing inside, cans that shipped by the millions to board makers who had no idea. A tiny gap in a recipe was now baked into hardware worldwide. The formula was broken, but a broken recipe on paper doesn't dent a single computer. So what actually happens inside the can when you flip the power on? Here's where the chemistry turns physical. Flip the power on and current flows through that soaked paper spacer. In a healthy cap, everything stays stable. In a plague cap, the missing suppressor is the problem. The water-based electrolyte reacts as it works. And with nothing to hold it back, it steadily splits water and pumps out hydrogen gas. Gas needs room. But this is a sealed metal can. There is nowhere for it to go. So pressure climbs. Every hour the machine runs, a little more gas, a little more pressure, pushing outward on walls that were never meant to bottle a growing balloon. Watch the top of the can. Manufacturers score it with a shallow cross or a stamped groove, a deliberate weak seam, a pressure relief vent. When the internal pressure crosses a threshold, that scored seam is designed to give way instead of the whole can exploding. So the flat top domes upward first. Then the seam splits along those score lines. And now the seal is broken. Here's the ugly finish. With the top vented, that wet electrolyte, corrosive, acidic, starts to weep out. It creeps down the sides of the can and pools onto the circuit board below. On the board, it does two nasty things at once. It eats away the thin copper traces that carry signals, and it bridges points that were never supposed to touch, quietly shorting them together. So the cap doesn't fail alone. It takes the board with it. And because every capacitor in that bad batch carries the same broken recipe, they don't fail one lonely part at a time. They fail in clusters, on the same board in the same machine, often within weeks of each other. One missing ingredient multiplied across a whole batch becomes a synchronized wave of destruction. That's the inside story. But what did any of this look like to the person just trying to use their computer? So here's what it looked like from the couch. First, the flaky stuff. A PC that froze for no reason. Random restarts mid-sentence. A TV that took 3 tries to turn on, or showed lines and dead patches across the picture. Nothing you could point at. Just a machine slowly losing its mind. Then the visible tell. Anyone who cracked the case open saw it instantly. Capacitor tops domed up like tiny muffins. And around their bases, crusty residue the color of dried blood or burnt orange. The dried remains of leaked electrolyte. Once you'd seen one, you couldn't unsee it. And there was a pattern to which ones died first. Heat is the accelerator. The reaction that makes the gas runs faster the hotter it gets. So the cap's packed right next to the processor and the power regulation parts. The hottest neighborhood on the board, cooked fastest. The hottest caps died first every time. That gave repair techs a shortcut. They stopped guessing. They'd open a dead board and look straight at the cluster near the chip. Find the domed, weepy cans and you'd found the killer. And here's the almost hopeful part. Because the rest of the board was usually fine. The chips, the traces, the connectors all still good. The fix was often just those caps. A tech would desolder each bulged can and solder in a fresh, properly made one. 50 cents of parts and a steady hand. Dead machines that would have gone straight to the dump booted right back to life. Whole forums grew up around it. People teaching each other to spot the bulge and bring boards back from the grave. So we've seen the recipe, the gas, and the graveyard. Now let's put the whole chain together in one clean line. So here's the whole chain in one breath. A stolen electrolyte recipe was missing one gas-suppressing additive. Without it, the wet cap generated hydrogen as it ran. Pressure built, the scored top vented, and corrosive liquid leaked onto the board, eating traces and shorting circuits. Multiply that by millions of cans in millions of machines. And one omitted ingredient cascaded into billions of dollars in losses and mountains of electronic waste. That's the master loop closed. Not bad luck. Not 100 separate factory mistakes. One broken copy of one recipe. So how did the industry climb out? 2 ways. First, the honest makers tightened quality control and got their real formulas, additive included, back under lock. Second, and bigger, the industry shifted towards solid polymer capacitors. The ones with conductive plastic instead of liquid. No wet electrolyte means no gas to build and nothing to leak. That's why the shiny black and silver solid caps you see on modern motherboards exist. They were the industry's answer to the plague. And you can still read the scars. Crack open a machine from that era and the bulged, crusty cans are a fingerprint of exactly this failure. A 2-cent part that told on the recipe that made it. One omitted ingredient in a copied recipe killed millions of PCs, TVs, and monitors. Proof that the smallest part can carry the biggest failure. So go check your own drawer of old electronics. Pop the case, look at the little silver cans near the hot chips, and see if any tops are domed. Next time we open the power supply itself, and the transformer that turns wall voltage into the gentle trickle your laptop actually drinks.